in previous class, previous semester rather, about TCP. So what we have seen in the previous semester, we have seen four algorithm for normal TCP, and those four algorithms are uh, slow start, congestion avoidance, fast retransmit, and fast recovery. So when TCP was invented, uh, TCP was majorly for wired environment, wired environment, where the bit errors used to be negligible. And there is a inherent assumption that whenever there is a packet loss, it is due to congestion. Because in wired network, in a guided media, bit errors due to environment, the loss is negligible. And whenever there is a loss, we thought that it is a congestion, and then we deployed these four algorithms. Now, if we talk about wireless, the whole assumption is gone. Because in wireless, it is unguided media, there would be lot of bit errors. Now, if we apply the regular TCP as it is, whenever there is a bit error, CRC will not match at the receiver. The value which you include with the header, a checksum will not match, and the acknowledgement will not be generated. And if acknowledgement is not generated, sender will time out and sender will enter into slow start. Or if any one or two packets are erroneous, so you may get many duplicate acknowledgements, you may enter into fast retransmit. If a window worth of data is lost due to bit errors, you may enter into slow start. If you think about wireless environment, it is, and that too, if it is mobile also, it is intermittent connectivity. So you get connected, then you may have, if you are mobile, you may reach in an area where there is no network, then again you are connected, again disconnected. So there are two issues. One is bit error, and due to mobility, your disconnection. Now, what we want opposite of that. Because there is an intermittent connectivity, we want that whenever there is a connection, we should download or we should utilize the network full throttle. But what actually is going to happen if you deploy these four algorithms, means if you use the original TCP, if there is any packet loss, that will lead to congestion control and you'll slow down your data transmission rate. What is slow start? You come back to congestion window 1. What is fast transmit? Your congestion window becomes half. Now, as soon as you enter into wireless environment, the whole assumption of TCP, the assumption on which TCP was based upon, that there are negligible bit errors, there is no mobility. So 99.9% of the time, if packet you are not getting acknowledgement, it is due to the congestion and your packet is dropped. And that becomes a challenge in a wireless environment. TCP is important protocol. You cannot avoid this because your web is based on that. Now, what are the solutions? What should we do? Priya, you got the question, Priya?
Yes, sir.
The TCP which is getting used is for wired. Packet loss leads to congestion control. TCP which we want to use for wireless, packet loss is generally due to bit errors and mobility, which is not direct indication or im- implicitly we cannot say that there is a congestion. It may be congestion also, but what is the solution?
Sir, for bit errors, if it is majority, we can use checksum.
No, checksum is always there, but what TCP does, if the packet is having error, what TCP will do? TCP will receiver will sit silent. Remember on the finite state machine?
Yes.
It will not send a, because there is no positive or negative acknowledgement. There is one acknowledgement or lack of acknowledgement.
Yes.
So if you don't send any acknowledgement,
How
the
to send that send it.
original TCP will consider it's a packet loss and will enter into congestion control, slow start, congestion avoidance, and so on and so forth. The four algorithm which we have discussed. What is the solution?
So then we have to send acknowledgement like that. Will be the same. Like we,
So you have to send positive and negative acknowledgement.
yes, sir.
So you will say that. So it means in your system, in your laptop, you'll be having two TCPs. TCP for wired and TCP for wireless. Yes?
Okay. So we need a way to reuse the wired one.
You cannot have this.
Yes.
And if you change the TCP, you have to change the application also. No? So you'll
Yes.
say that no, no, this WhatsApp app will run on wireless. So
Mm.
right now I'm moving from wired to wireless. So I need to change the whole protocol stack. Mhm.
Mm. No, sir.
That's not possible. So that was the biggest challenge. And there were too many solutions which have been proposed that how we can you cannot entirely change the TCP because TCP already has a huge installation base all over the world. TCP is already installed as part of operating system, and if you want to have a seamless connectivity, that's why we have studied mobile IP and all. um, if you start saying that we need an entirely different TCP, that is not going to be possible. Then this type of approach that two different TCPs, one for wireless, one for wired, again it is not possible. So what were the proposals? There were many proposals. Some are good, some are bad, some were adopted, some have been pushed towards the RFC status. So what actually TCP is doing nowadays is not going to be covered in this lecture. I'll just tell you the approaches with which people have started. So nowadays, what is from 2012 in Linux kernel, we use Eiffel algorithm and the concept of spurious timeouts. The timeouts which are spurious means which which are due to something else instead of a normal packet drop. So beyond 2012, we do have this particular provision in Linux kernel, but as of now, this is out of your scope. I would have taught this in detail if classes used to be regular. Fine. So this time uh, we are not getting time for this. Spurious timeouts, and I feel that is the real implementation. I'm just telling you for your knowledge that we do have a tweak where TCP can actually attempt to find out whether this timeout is happening due to congestion or happening due to a bit error. That's what you want, Priya?
Yes, sir.
If you can figure out that why this timeout is happening, fine. So that was the approach finally was adopted, and it is there in Linux kernel, in Apple kernel. Fine. I don't know about Windows because Windows Mobile Edition not became popular. Fine. So we'll see other different approaches which actually led to this. The failure of those approaches led to entirely new way of thinking, and we reached to this Eiffel algorithm. Eiffel was the initial thing, and then spurious timeouts and things like that. So what was the first approach which they have followed? So if you see a little bit in 802.11, we have concept of acknowledgement. Remember, we send
Yes, sir.
packet and then we get the acknowledgement. This is MAC layer. In TCP also we have concept of acknowledgement. No, so these acknowledgement are happening end to end TCP acknowledgement, and this 802.11 acknowledgement is happening from towards access point to the node. If you see the wireless environment, it would be an access point, and then there would be a mobile node which is wirelessly connected. And this AP is a part of wired network, as you can see in your institute also. And the corresponding node may be a wired node or wireless node. So if you see what is happening, only the last mile, be it your mobile phone or be it your laptop, which is wirelessly connected, only the last mile is wireless. If you're talking about TCP acknowledgement, they are happening end to end. If you're talking about 802.11 MAC acknowledgement, they are happening between AP to mobile node. Got the point, Priya?
Yes, sir. Got it.
This is wireless acknowledgement, and this is TCP acknowledgement end to end. Now, what was the first approach which was followed by some researchers, which was actually not, which was suggested by researcher, was named as split connection approach. I'm telling you the approach, and then you think about the possible pros and cons. What it was telling that there is a fixed node, and then there is your access point or base station, and then there is a mobile node. What was the suggestion? That fixed node to mobile node TCP connection, which you established as a virtual connection, is divided into two parts. One TCP connection between fixed node to AP, and another TCP connection between AP to mobile. So instead of a single TCP connection, this is vis-a-vis your proxy, which we have discussed. So this part of TCP need not change because this is the wired TCP as before. And this part of TCP, you can do little bit of changes or modification or tweaks because here only the wireless aspect is there in this portion. Got the point?
Yes, sir.
So what is happening? Whatever data is coming will come to AP. AP will relay the data to mobile node. So this is a TCP connection on wireless and this is the TCP connection for wired. And AP using its acknowledgement of MAC layer may keep on retransmitting here. What are the issues? Suppose I send here packet number 1, 2, 3, 4, 5, and 6. So these packet will go on this small TCP connection between AP and fixed node. And they will be received here 1, 2, 3, 4, 5, and 6. And these packets will be acknowledged by AP on this TCP connection. Now what fixed node is thinking that the ultimate destination, which is a mobile node, has got these packets. Now AP will relay this packet. There would be packet loss, drops, fine. So some of the packets will be retransmitted using ACK of MAC layer. If there is a timeout, then TCP will slowly and gradually transmit, retransmit, retransmit, retransmit TCP at this part. So there is a violation of end-to-end semantic. You are thinking you have transferred the data to mobile node, but actually data has not been transferred actually to mobile node because mobile node are not sending acknowledgement to fixed node. It is at the access point which is sending acknowledgement to fixed node. And for that entire duration, AP has to buffer these packets. Yes or no?
Yes, sir.
So this was one issue. Another issue, suppose mobile node moves and joined another AP, AP2. So fixed node is unaware about this thing because fixed node has transferred these 6 packets. Fixed node has got the acknowledgement. Fixed node is thinking that packet has been delivered. This AP might have delivered only 3 packets till now. And MN has changed the location and joined to AP2. MN is now here. Now what? Yeah, Priya.
So can,
Now what?
so can you repeat the last one?
Hmm? Suppose fixed node had transferred 6 packets. AP has received 6 packets. AP has sent the acknowledgement on this part of TCP connection. Now fixed node is having a knowledge that I have delivered all the packets. Because this is a
Okay.
wireless TCP connection, here lot more number of retransmission may happen both at MAC layer and transport layer. So AP might have only successfully transferred 1 and 2 packet.
Okay.
And meanwhile, MN moves.
Oh,
So what should
okay.
we do? What should we do in this case?
Sir, as soon as AP receives 1 and 2, it will send it to MN, right? Like 1 and 2 has been received by MN or before that MN has been?
MN 1 and 2 have been received by MN. 3, 4, 5, 6 is still remaining. Fixed node is not going to send them again because fixed node has got the acknowledgement up till 6.
Okay. And MN will have already acknowledged 1 and 2, right? So then it will
MN has just acknowledged 1 and 2, but that acknowledgement will reach up to AP only because this is another connection.
this one. Sir, okay. Assuming MN moves, after that, if AP receives 3 and it will try to send to MN, right? But it will not receive acknowledgement. So AP should also tell the fixed node to
No, no, no. AP has already received. Here, AP has already received 6 packets, has
yes.
sent acknowledgement for 6 packets.
Oh, then this is the issue.
But AP was not able to transfer to MN because this was the fixed area, no? Wide
Yes.
area. Here things are happening smoothly. This area, this particular portion is wireless. Here there would be lot of retransmissions due
And
to
then
bit errors and
only solution is that if AP knows that it has moved to AP2 and it sends to AP2, but then that is not
then you
that.
have to send all these packets back to the AP2. The packets which have been uh, unacknowledged and sitting at the AP1.
Yes.
So you need to maintain the whole state. And this is really cumbersome in case of mobility. Got the
Yeah.
point? Hmm? So that was the first approach that has been suggested, but that was having lot of issues. And in case AP crashes, then after sending acknowledgement back to fixed node,
Yes, sir, that is complete packet.
that would the permanent loss of data because fixed node will have no means to know that the packet have been lost. Okay, because
Yes.
fixed node assumes that I got the acknowledgement.
But this is the case even for like normal wired TCP connection, right? Like if a middle intermediate node fails, it has already acknowledged so before transferring, right? So the same issue can occur there also.
So there the middle node is your proxy, which is HA, high availability server.
Yes, sir.
Here you are talking about AP,
Which is not. Yes.
which is not. Here it is a proxy server which is having all the layers right from application to um, physical. Here the AP is actually a layer 2 device, but you need to make it TCP aware. Fine. So your AP becomes
Right.
costly. AP would cost around then 2 lakh rupees.
Yes, sir.
And that too having lot of memory, then it will go to 5 lakh. Will you purchase a 5 lakh AP?
Uh,
Are you getting my point? Not. And that's why this approach was not followed. So what was the issue in this approach? The end-to-end semantics were violated. So next approach which was uh, proposed was known as Snoop TCP. All these things are available in slides. So you can see the slides. Snoop TCP. Here, end-to-end semantics are retained. End-to-end semantics are retained. And instead of making a hard state at AP, we maintain a soft state. I'll just explain that. What is happening? We have a fixed node, then a wired connection up to AP, then we have a wireless connection towards mobile node. So whatever fixed node is sending, the data is getting buffered. So there is no split connection. TCP connection is still between FN and MN, end-to-end connection. So what AP is doing, AP is just buffering the packets, whatever fixed node is sending. It's relaying the packets one by one, but buffering the packets. Now what will happen? Just see the condition. Suppose FN has sent 1, 2, 3, 4, and 5. Because it is on the wired part, these 1, 2, 3, 4, 5 are buffered here. Got the point?
Yes, sir.
FN has sent 1, 2, 3, 4, 5. AP has received 1, 2, 3, 4, 5 packet. Now AP has relayed this 1, 2, 3, 4, 5. Suppose one packet is lost or is having error, or one is received correctly at MN, two is lost, or having error, and 3, 4, 5 are received. So when one is received, MN will send an acknowledgement, ACK 2. One is being received, MN has sent acknowledgement ACK 2. This will reach to AP, and AP will forward this acknowledgement because everything is fine. 2 was having error, and 3, 4, 5 was received. So when 3 is received, MN will send a duplicate acknowledgement, again ACK 2. But this ACK2 duplicate one will also go through AP. Now in this case, AP will not forward this duplicate acknowledgement back to FN. What AP will do? AP will be aware about TCP. Aha, there is a duplicate acknowledgement. It means 2 has been lost or having error. So AP will retransmit packet number 2 and will drop this duplicate acknowledgement. Got the point, Priya?
Yes, sir.
It is just having a watchdog over there, snooping the things. How many packets have been sent from AP? And how many correct acknowledgements have been received? If correct acknowledgement have been received by AP, the AP will forward those acknowledgement back to fixed node. Otherwise, what AP will do, as and when AP finds a duplicate acknowledgement, what AP will do? AP will retransmit from its buffered packet only and not telling FN that packet has been dropped. So whatever the errors, what is the error prone area? Error prone area is this, the wireless area. And what this Snoop TCP is trying to do is trying to limit or confine the error in this area only. And AP is doing its job, snooping the acknowledgement, snooping the packets, and working in between. But there is no split connection of TCP. Still, there is only one connection between FN and MN. Got the point?
Yes, sir.
What are the issues here?
Sir, again, we'll have to, like, if we are managing soft state, uh,
Why it is
and
a soft
like,
state? Why it is a soft state?
sir, because it is mutable.
No. Look, there's a difference between the state we maintained at in split connection and state we are maintaining here. The state in TCP, suppose here MN moves to another AP. and you don't transfer any buffered packet in this AP, what will happen?
It will be lost.
Permanently lost?
No. Okay. So that's where soft state can.
You got the point. सपोज ये नहीं भेजता है, ये 1 2 3 4 5 MN मूव कर जाता है और उधर फिक्स नोड भेजता है पैकेट नंबर 7, इस एपी पे
Hmm.
आएगा, MN कहेगा आउट ऑफ ऑर्डर है, सेंड मी
Hmm.
ACK2।
Hmm.
तो ये ACK2 यहाँ पहुंचेगा। ठीक है, इसके पास अगर कुछ बफर नहीं रहेगा नए एपी के पास, तो एपी क्या करेगा, बफर ही नहीं है इसके पास, तो पीछे भेज देगा ACK2। तो FN क्या
हाँ
करेगा, 2 से फिर भेजना शुरू कर देगा।
हाँ समझ रहे हैं।
So there is no permanent loss of data. That's why it is a soft state.
हाँ,
So even if you don't transfer the soft state to next AP, there would be no problem in correctness. Efficiency may be hampered.
yes sir.
So whenever we work for efficiency, we always say it's a soft state. Remember DHT, core DHT?
Yes sir.
The hard state was a successor pointer, but finger
Yeah.
table was soft state, no?
Yes sir.
Finger table was only for for efficiency, not for correctness. In split connection approach, because it was a hard state, and if you don't transfer the buffered packet to the
It
next
is.
AP, packet may be permanently lost because FN knows that FN is under illusion that it has transferred the packet and it has got the acknowledgement.
Yes sir.
Now you got the point. So that is a difference between uh, ITC that split connection approach and this Snoop TCP. Another issue in Snoop TCP is if the packet is encrypted. Got the point? Suppose you are using IPsec tunnel mode. Everything of TCP header would be encrypted, no? So you'll not be able to see which number packet, which sequence number packet, and which acknowledgements are coming. Got the point?
Yes sir.
So these are the two approaches which we're trying to uh, obviously in all of these approaches you'll find that they have done they have tried to divide the whole communication path into two parts, wireless part and wired part. The split connection approach uh, was at one limit that it is actually making two TCP connections, and this Snoop is not making two TCP connection, but is still having a TCP awareness at AP, and it's maintaining a soft state so that it can do the local level retransmission, local wireless level retransmission without actually informing back to the uh, fixed node about the packet loss. अच्छा एक बात बताओ,
Yes sir.
if we delay the duplicate acknowledgement. I'm giving you a situation. There is a fixed node. There is a AP and then wireless mobile node. So I'm sending packet number 1, 2, 3, 4, 5. AP received 1, 2, 3, 4, 5. AP transferred 1, 2. These packets. 1 was received correctly. 2 was having error. 3 was received correctly. 4 received correctly. 5 received correctly. So as soon as 3 will be received, remember the TCP, if duplicate acknowledgement is there, if you get out of order packet, don't delay the duplicate acknowledgement. Remember in TCP? As soon
Yes.
as you receive the 3, you will send a ACK 2.
Yes.
What I'm saying, when you receive 3, you just delay this duplicate acknowledgement. I'm giving you another approach which was proposed by one professor in IIT, fine, IIT Mumbai,
So
in one of the
then
paper.
delay will just cause a timeout on the AP, and basically it will.
On the AP is not maintaining any connection.
Yeah.
If you delay the duplicate acknowledgement, what benefit we can get? Now, what was the argument given by that professor is, if you delay the duplicate acknowledgement at TCP level, the MAC layer may get some chance to work upon. So why 2 was lost? Either 2 was having error or 2 was completely lost during the path. Hmm? Yes?
Yes.
AP is working 802.11. AP might have sent packet number 2. It was received, not received here. It has sent 2, 3, 4, all packets. 2 was received but having errors. Transport layer could not generate acknowledgement for 2. Transport layer received 3. Transport layer will try to generate duplicate acknowledgement. I am saying delay this. So what will happen at MAC layer of AP? AP has sent 2 but could not receive ACK for 2.
Yes.
So if you delay the duplicate acknowledgement at transport layer, that will give chance AP to use its retransmission at MAC layer. Got the point? That
Okay.
was the hunch. नहीं समझ में आया?
नहीं सर, तो मैक लेयर पे भी टाइम आउट तो.
मैक लेयर पे टाइम आउट नहीं होता है. देखो क्या होता है. एनएवी होता है ना.
यस सर.
और एक्नॉलेजमेंट नहीं रिसीव होता है जितनी देर में होना चाहिए था, तो वो दोबारा भेजता है.
ओके.
तो अगर ट्रांसपोर्ट लेयर वाला तुम डिले कर लोगे, ये किताब में नहीं मिलेगी अप्रोच, ये स्लाइड में है मेरे. इफ यू delay the duplicate acknowledgement a little bit, MAC layer can get chance to retransmit that. पढ़ना 802.11 पढ़ा चुका हूं भाई, ठीक है.
सर एनएवी के बारे में ज्यादा नहीं पता है.
बताया था आपको नेटवर्क एलोकेशन वेक्टर. ठीक है. कितना बड़ा पैकेट होता है, कितना साइज होता है और कितना चैनल का स्पीड है, उसके हिसाब से एनएवी डिसाइड होता है. स्लाइड दिखाऊं क्या?
ओके ओके सर, याद है. ठीक है सर.
हाँ, नीचे एक ब्लू कलर की लाइन नहीं बनाई थी एक. ठीक है.
कैरेट कैरेट.
ठीक है. नेट एलोकेशन वेक्टर. कितनी देर तक एलोकेट करेगा ये पर्टिकुलर पैकेट. ठीक है.
हाँ सर.
SIFS DIFS वो सब टाइम थे ना. उतनी
यस
देर
यस
में
यस.
एक्नॉलेजमेंट आ जाना चाहिए. नहीं आ
हाँ.
रहा है तो वो रिट्रांसमिट करेगा. ठीक है. हम्म.
गॉट इट.
So that's what is was the approach by that professor. Was published in one of the paper. I was attending his paper presentation way back in 2006, and then that particular approach was discussed. But here again, the issue in duplicate acknowledgement is how much you can delay. How much you can delay? It is very difficult to choose a delay time. It has to be adaptive depending upon the properties of that wireless channel. Again, you can think about this, and I've included the slides for these also. Delayed Now, I'm going to tell you another approach which was known as MTCP. Now, what is this? This is interesting. Please be with me. MTCP is like split connection. MTCP is like in split connection. So there would be fixed node, then AP, and then wirelessly connected mobile node. Just a minute. इसे नीचे करना पड़ेगा ना तो अप्रूवल नहीं होगा भाई 6U रैक हम दे ही रहे हैं बाकी अधिकतर सामान हम देंगे वो अलग से मंगा ₹2000 का सारा एजेंट है गधा है यार कुछ नहीं पता है वजह से कुछ बनवा नहीं वहां तो मैनेज ही लगा रहे मैंने 10,000 का आया था स्विच हाँ बड़ी पीजी छोड़ के मंगाएंगे बड़ी वाली बड़ी लगा देगी ऐसा नहीं तो बड़ी लगा देगी सब क्लास ले लेते ना now what is this MTCP MTCP it again splits the connection there would be two TCP connection here and TCP connection here two connection similar to our split connection approach. Now, why this MTCP came into picture? We need to think about this. Suppose there is a situation like this. There is a AP1 and after a long distance, there is a AP2. Means if a MN is moving from AP1 to AP2, it will be a long disconnection. If there is a long disconnection, MN will take a lot of time to, so MN will be in a area which we say is a blind spot. There is no connection, no network coverage. But MN is already communicating with fixed node. So what will happen? There would be regular retransmission, and your window will become very small. So whenever it gets connected, due to lot of retransmission, lack of connectivity and lack of acknowledgement, window will become very small. So even if MN get attached after disconnection to another access point, it will be a long time before FN could actually start the data transfer because you're already, so you know that every time retransmission timeout gets doubled. Fine. If you send the acknowledgement and retransmit, then RTO gets doubled. So AP RTO loop में चला जाएगा और FN RTO loop में चला जाएगा. MN connect भी हो जाएगा तब भी FN कुछ नहीं भेज पाएगा because it is waiting for RTO. And for to solve these things, what MTCP suggested, It monitors all the packets, the AP. यहाँ से जितने पैकेट आ रहे हैं और यहाँ से जितने एक्नॉलेजमेंट आ रहे हैं, दो टीसीपी कनेक्शन. And what AP does, as soon as this connection is experienced at the MAC layer, MAC layer पे जब MN मूव करेगा, सिग्नल स्ट्रेंथ कम होगी MN की, और फिर वो अपना एक कंट्रोल मैनेजमेंट फ्रेम भेजेगा. Disconnection, deauthentication, authentication, association, disassociation, these frames will be sent from mobile node. As soon as AP knows this thing, कि यार ये MN भागने वाला है या दूर जा रहा है. So what AP will do on this connection, this part of connection between F and AP, it will send a zero window advertisement. Remember zero window advertisement? TCP का remember? कि जब बफर कुछ नहीं बचता था तो टीसीपी भेज देता था जीरो विंडो एडवर्टाइजमेंट. फिर जो सेंडर होता था थोड़ी देर बाद एक परसिस्टेंस टाइम आउट के बाद वो भेजना शुरू करता था डमी पैकेट. हाँ, तो एपी को जैसे ही पता चला अपने मैक लेयर से कि डिस्कनेक्शन होने वाला है, एपी ने क्या किया, इस वाले टीसीपी कनेक्शन पे जीरो विंडो एडवर्टाइजमेंट भेज दिया. तो एफएन क्या हुआ, एफएन चुप हो गया, शांत, स्टॉप्ड, स्टॉल हो गया. जैसे ही एमएन कनेक्ट हुआ दूसरे एपी में, अगेन एमएन गॉट कनेक्टेड. तो एमएन क्या करेगा, जो भी उसके जो एपी क्या करेगा, एफएन को बता देगा नया एपी.
यस सर.
क्या बता देगा कि नाउ
Looking at
कनेक्शन इज देयर. तो एफएन स्टार्ट कर देगा ट्रांसफर. नाउ व्हाट हैज हैपेंड इन हियर, देयर वुड बी नो कैशिंग, नो retransmission. As soon as this connection is detected, you have stopped the FN. FN कुछ भेज ही नहीं रहा है तो टाइम आउट नहीं हो रहा है, टाइम आउट नहीं हो रहा है तो रिट्रांसमिशन नहीं हो रहा है, रिट्रांसमिशन टाइम आउट नहीं हो रहा है, नेक्स्ट रिट्रांसमिशन टाइम आउट नहीं हो रहा है. एफएन तो चुप बैठा हुआ है. जैसे एमएन दोबारा कनेक्ट हो गया, फिर मैक लेयर से पता चला कि कनेक्ट हो गया है, उसने एफएन को बता दिया समहाउ कि आप यार शुरू कर दो. तो दिस वाज द अप्रोच नोन एज एमटीसीपी, मोबाइल टीसीपी. कैसे बताएगा दोबारा, ये सोचो. स्प्लिट कनेक्शन से एक चेंज भी हुआ इसमें. एफएन, एपी, mobile node. In split connection, what was happening? These two TCP connection, FN was sending data to AP, AP was acknowledging. And then AP was relaying the data to MN, MN was acknowledging. So these were purely split connection, in a split connection approach. Here what is happening, FN is sending data to AP. AP will not acknowledge back to FN on this TCP connection, TCP1, until unless AP receives an acknowledgement from the MN. कनेक्शन दो हैं, लेकिन AP एक्नॉलेजमेंट FN को तभी करेगा जब MN से उसके पास एक्नॉलेजमेंट आ जाएगा.
सर, तो ये भी एंड टू एंड हो गया.
एंड टू एंड है लेकिन कनेक्शन दो हैं.
हाँ
ठीक है, इसका पर्पस दूसरा था, लॉन्ग डिस्कनेक्शन के लिए. ठीक है. अब एक जुगाड़ किया इसने. ठीक है, व्हाट वाज द जुगाड़? सपोज यू हैव FN has sent 1 to 500 packets. AP has relayed these packets 1 to 500. Until unless MN acknowledge करेगा, AP आगे नहीं भेजेगा acknowledgement. तो 1 से 500 AP को मिले, AP ने 1 से 500 भेज दिए. AP क्या करेगा? 500 का acknowledgement रोक के रखेगा हमेशा. थोड़ी देर रोकेगा. Withholds the acknowledgement. 1 से 500 आया, उसने 100-500 भेजा, अपना ट्राई किया, रिट्रांसमिट किया. इस वाले टीसीपी पे खूब सारे रिट्रांसमिट होंगे क्योंकि erroneous है. और जब एमएन से एक्नॉलेजमेंट आ जाएंगे तभी वो पीछे भेजेगा. बट लास्ट पैकेट के एक्नॉलेजमेंट को वो रोक के रखेगा. वो नहीं भेजेगा. तो एफएन को लास्ट बाइट का एक्नॉलेजमेंट नहीं मिलेगा, लास्ट पैकेट का. अब इस मोमेंट पे अगर एपी को पता चला कि डिस्कनेक्शन होने वाला है, एपी के पास क्या है? 500 है. ठीक है, 500 उसके पास बचा हुआ है. आप सोच के बताओ.
फिर भी भेज देगा, जीरो हो गया.
हम्म,
100 बचा हुआ है, फिर भी
सोच के बताओ.
नॉट श्योर.
इसने रोक के क्यों रखा हुआ है?
ताकि गारंटी हो सके एफएन को कि मोबाइल नोट तक पहुंचे.
एक बचा के क्यों रखा है? कितना हिंट दे दिया, सोचो.
हाँ, यही मेक श्योर करने के लिए कि लास्ट पैकेट आया उसके बाद ही भेज.
ना, परसिस्टेंस मोड से बाहर भी तो निकलना है.
ओके. हाँ. हाँ, persistent
से
बाहर
बाहर
निकलने के
भी
लिए लास्ट.
निकलना है ना. और
हाँ.
बाहर निकलने के लिए इधर से कुछ भेजना जरूरी है हमको.
यस सर.
हम्म.
हम्म.
तो जब हम रिकनेक्ट करेंगे तो हम इस 500 वाले एक्नॉलेजमेंट को यूज कर लेंगे. न्यू डेटा है, न्यू एक्नॉलेजमेंट है.
करेक्ट
और
करेक्ट
इसके
करेक्ट.
साथ नई विंडो भेज देंगे, बड़ी
यस
वाली.
सर.
गॉट द पॉइंट. एंड दैट्स व्हाई it is withholding the acknowledgement. Think over it. Any confusion you can ask. 2-3 minutes. You want to think, you can think it. फिर से बताता हूँ, इंपॉर्टेंट है, इस पे क्वेश्चन आ सकता है. ठीक है. We have, there is a FN,
यस सर.
there is a AP, MN. There are two connections, TCP1 and TCP2. FN is sending packet to AP. AP is relaying the packet to MN. AP is not sending acknowledgement back until unless it received the acknowledgement from MN.
Yes.
AP withholds the last acknowledgement, 500 वाला, एक अपने पास बचा के रखेगा हमेशा।
Yes, sir.
तब तक दूसरा आ गया तो बात अलग है। एक हमेशा एक्नॉलेजमेंट बचा के रखेगा। उसने अगर यहाँ से 10 भेजे, उसको 10 एक्नॉलेजमेंट मिल गए, तो 9 तो आगे भेजेगा, 10वां बचा के रखेगा।
सर लास्ट एक्नॉलेजमेंट ना मिलने पे भी एफएन नेक्स्ट पैकेज शुरू कर सकता है।
हाँ,
500 वाला उसको एक्नॉलेजमेंट नहीं मिलेगा तो नेक्स्ट पैकेज जो भी उसे भेजना होगा वो।
किसको? FN को?
हाँ।
FN की विंडो तो बढ़ ही रही है, 9 तो भेज ही दिए तुमने ना।
हाँ उसमें ओके ओके।
10 पे अटका रहेगा केवल। ध्यान नहीं है TCP विंडो कैसे चलती है। 9 मिल जाएंगे तो CWND तो बढ़ती जाएगी ना, ऑन
यस
एवरी
सर।
एक्नॉलेजमेंट +1 होगी। 10वां बचा के रखेगा, फिर
हाँ
10वां ही मिल जाएगा, 11 मिल गया, 12 मिल गया, तो एक को हमेशा थोड़ा भी डोल करेगा। ठीक है।
ठीक है।
इस इन बिटवीन अगर AP को पता चला कि डिस्कनेक्शन होने वाला है, ठीक है, तो AP क्या करेगा? इस जो बचा हुआ एक्नॉलेजमेंट उसको यूज करके ZWA भेजेगा। बात समझ में आई?
यस सर रीयूज सेम वो यूज हो गया।
क्योंकि ZWA भेजने के लिए भी तुमको एक एक्नॉलेजमेंट
एक्नॉलेज।
चाहिए ना,
यस सर।
और न्यू डेटा का एक्नॉलेजमेंट चाहिए, नहीं तो वो रिसीव ही नहीं करेगा FN।
यस सर दोनों यूज के लिए एक रखना है।
ये तो ये हो गया। जब MN नए AP पे आएगा, ठीक है, MN ज्वाइन करेगा, ठीक है, तब हम इस जो MN ऑलरेडी रिसीव कर चुका है कुछ, ठीक है, वो एक डुप्लीकेट एक्नॉलेजमेंट भेज देगा या कुछ कर देगा, ठीक, जिससे कि FN वहीं
हाँ
से शुरू हो जाए। गॉट द पॉइंट? या FN परसिस्ट टाइमर में होगा, परसिस्टेंस वो भेज ही रहा होगा, ठीक है, तो MN बता देगा। गॉट द पॉइंट? तो जो रुका हुआ एक्नॉलेजमेंट है, दैट इज गेटिंग यूटिलाइज फॉर सेंडिंग ZWA। पर इसमें भी एक इशू था। क्या इशू था? कि हमको जो AP है उसको TCP अवेयर करना पड़ेगा। कनेक्शन 2 रखने पड़ेंगे।
हाँ सर वो है।
तो एक आखिरी अप्रोच आई, नोन एज फ्रीज TCP। इसी फ्रीज TCP को यूज करके हमने एक SDN इनेबल्ड TCP का एल्गोरिथम बनाया था। फाइन, इफ यू वांट टू स्टडी आई कैन गिव यू दैट पेपर। You just write down Mayank SDN TCP enhancement, you'll get that paper. What is freeze TCP? मैं बताऊं, जैसे AP को पता चल रहा है सिग्नल स्ट्रेंथ देख के कि मोबाइल नोड दूर भागने वाला है, वैसे MN को भी तो पता चल सकता है ना मोबाइल नोड को कि हम AP से दूर जा रहे हैं।
यस सर वो
देखा
सामने से।
देखा है ना अपने सिस्टम में कितनी डंडी आती है।
हाँ
और जो मैक लेयर है उसको बहुत पहले पता चल जाता है, क्योंकि हम दूर जा रहे हैं, दूर जा रहे हैं, दूर जा रहे हैं। तो इंस्टेड ऑफ AP टेलिंग sending ZWA, MN can do that thing. तो कनेक्शन भी स्प्लिट नहीं करना पड़ेगा। थिंक ओवर इट।
यस सर।
If MN can send ZWA 1 RTT before handoff, your work is done.
यस सर।
तो यहां पे क्या होता है, यहां पे फिर वही है FN AP MN, कनेक्शन एक ही है, there is no split connection. AP is not monitoring or snooping or doing anything whatever it was doing in split connection and MTCP. MN अपना एक एल्गोरिथम चला के रखता है कि हमारा डिस्कनेक्शन होने तो नहीं वाला है, जैसे ही एमएन को आइडिया होता है कि भाई हम डिस्कनेक्ट होने वाले हैं, एमएन विल सेंड ए ZWA। वो ZWA एपी के थ्रू यहाँ चला गया, एफएन शांत हो गया। एमएन थोड़ी देर बाद दूसरे एपी से कनेक्ट हुआ। एमएन के पास जो भी डेटा मिल गया था उसमें से एक, जो उसने लास्ट रिसीव डेटा उसके पास था, उसको उठाया और 3 डुप्लीकेट एक्नॉलेजमेंट भेज दिए। जैसे ये 3 डुप्लीकेट एक्नॉलेजमेंट यहाँ एफएन के पास पहुंचे, एफएन कहाँ घुस गया? एफएन आ गया फास्ट retransmit में। Got the point? At 3 duplicate acknowledgement, we enter into fast
Yes.
retransmit. Remember? तो
हाँ सर।
एमएन का टाइम आउट भी नहीं हुआ, स्लो स्टार्ट भी नहीं हुआ, सीधे फास्ट रिट्रांसमिट, फास्ट रिकवरी में आ गया। गॉट द पॉइंट? तो यहाँ जो काम एपी कर रहा था एमटीसीपी में, वही काम मोबाइल
MN
नोड ने करना है। मोबाइल नोड ने करना शुरू किया। Fine. If there are any question you can ask. Otherwise, I'm uploading these slides also. Now, tomorrow's lecture would be last lecture, that is some mobile application concept and nowadays concept which are getting utilized in enterprise networks for mobility, and that would be our last lecture. And after that I'll share you all the previous year question papers also. Any
Okay.
questions? I'll upload the slides. Thank you.
Thank you, sir.